Hey, welcome to day 9 of Advent of Code in Dart. Okay, so we have a little bit of a sequencing sort of challenge here. You can read over it, of course, on your own, but essentially we're given some sort of lists of numbers like this that, ultimately we have to kind of figure out what the pattern is and then determine what the next number is. So, if we look at this first one here, it's pretty obvious that essentially it's just incrementing by 3, right? It goes from 0 to 3 to 6. So we know that this next one would be 18. However, the pattern's not always linear. Sometimes it's going up, multiple times. And the idea is that instead, so if we take this first one here, just to this one was what I just explained, but basically like we find the differences between each of them here. We know they're 3s. And then then we find the differences here. Essentially, if they're all the same number, they'll become 0. And we know we've kind of found like the lowest point that the pattern sort of starts. So we don't really know how many rows it will take until we've kind of run through a calculation. And then ultimately, what we would do is we'd append a number here, the difference between these 0, the difference between, and then the number here, if you add that next one up, 3. So A, B, da, 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 da. And we're ultimately trying to figure out this number. Like what is, at the very first line, what will the next number be? Again, pretty easy for a linear pattern like this, but you can see it get more complicated when this one goes 1, 3, 6, 10, 15, 21. So the difference is actually the row before. It goes up by 2, then 3, then 4, then 5, then 6. Which then we find, oh, that's where the linear one is, and that's where the 0 is, and we can solve for this because we work backwards, right? So it's like we know these are going up by 1, so we know that that's going to be a 7, and then we know the difference. And so on and so forth. It can get even more complicated in the third one where there's an extra line because it's going up by 3 and then 3. You're like, oh, it's the same, and then it's going up by 5. So there you have it. That's kind of what we're trying to do here, is really figure out that. So I didn't try to do this one live. I just was not feeling like it would be a good day. So I've kind of put together a solution here for the first one. It was pretty straightforward. So basically we do our normal thing. We get our input file. So I'm using the ground truth one here, which is the one in the sample. So there's 3 different things to run through. Importantly, the final result is a sum of all these final numbers in each line. So 68 plus 28 plus, 18. And that's the final answer we actually have to give, which is 114. So, we're reading the files as usual, parsing it, and then we're running into our solve function. And I'm basically going to solve each individually and sort of increment a sum as we go. So this will return that final number, and then we're just going to, do it. So the way the solve function works, so I have a solve kind of for each line. We start our I at 0. We are going to create a variable called passes, which is really just we're going to make essentially a list of lists. So we're just instantiating that values as the first item in that list, because the first pass, there's just going to be, one item in it. So we're just going to do a while loop here. That way we can kind of just repeat it, kind of almost like a recursive function, kind of, where we just keep running through this until, this is the key part, where our diffs, the length of the diffs that are all 0 is equal to the amount. So really this is just a simple line being like, are they all 0? And if so, we break out, and then we won't increment again because there's no need, because we're not going to go in this loop again. So what are we doing here? I'm just going to instantiate something called diffs. So this is going to be a list of the differences in there. And we're going to loop through each item in that current pass. So on our very first attempt, if we're looking at this, we're going to be looping through the 0, 3, 6, 9, 12, 15. And we're essentially going to, so I'm starting j, this variable called j, at 1 instead of 0. And then we're going to be less than the current path length, and then j, current pass length, and then increment j. That way we can kind of look at what j is, which j would be in the very first pass, the 3, because we're starting at 1, right? Indexes start at 0. So we're starting here, and then we're subtracting 1 on the j. So we're actually subtracting the difference between here and here. And we get this list of diffs. So in the very first pass, this will just be 3, 3, 3, 3, 3 as our diffs. And then it would go on to the next one. And because in the second loop, we'd have a bunch of 3s, when we subtract the differences, they'll be 0. And that's when this would kick in, and we're good. So that's essentially us just getting the differences of these things. And then essentially we're going to loop through all of our passes. We're actually looping through it in reverse order. So we're starting at I as basically the number of passes it took. Because what we need to do is sort of build this back up. So if we look at the example here, on the first pass, because we're starting here and our passes, we're adding, I forgot to mention this, but we're going to every time add in those diffs as the next pass, because that's really the next line that's being created. We're going to loop through them, and essentially we're going to add in this trailing number, taking the last thing in the diff. And then ultimately that will add up, and we can just go, and after those passes have been mutated, we can go, cool, all right, we're going to take the first pass now that it's been mutated and get its last item. And that's what we return from here. And then we are good. And if we just run this with ground truth, we can kind of see we get that 114 back, which is the example. So I got that working, and I ran it through, and luckily it worked. Now the second one, the second challenge is, actually, we want to, do this in reverse. So using the same inputs, instead of appending numbers, we're going to be adding them to the back of it. This confused me at first, but I realized, okay, it's actually not that different from what we did before. So let's open up number 2. So same kind of thing. We're going to solve each line separately. We're still, summing them together. And the difference is here, and maybe opening up both, you'll see these solutions are almost the same code. We still do this the same way. We still loop through this. We still are getting our diffs, but instead of appending it to the list, we're actually going to insert it at 0. And I realize we don't even use this I anymore. Oh wait, yes, we do, but we don't actually need it because we're not actually changing it. This could technically just be 0. And in fact, we can just go dot first. And the reason for that is because we're inserting, every time we do this pass, if we get the first item in the list, it's actually going to be different than the time before because we've inserted one before. So that's kind of the main difference. We're inserting, and then we don't really have to worry about incrementing I because we're essentially mutating the passes every time. And we get the first one back, but the first one's different. And then we do the same sort of thing. Then at the very end of this, it's just a little bit different. We're actually going to not do it in reverse order. We're just going to do it in forward order, get the, we're essentially, doing a normal for loop. And similar here, we're taking whatever our, this I is, so we're going to the next pass, essentially, and we're going to insert at 0 the last pass's value minus, so basically the same number, the last pass's value first item. So I'm a little bit confusing. And then we're going to subtract whatever pass we're in right now, its first item. And that's how we kind of build up this 0, 2, -2, -5, just by kind of subtracting this from this, this from this, that kind of thing. This from this. Anyways, so we get that, and that essentially constructs something, and then we just kind of reverse this. Instead of returning passes.first.last, we're actually returning passes.last.first. Remember, this is a list of lists, so passes.last would be, in this case, because we've kind of constructed this in reverse, the last one is actually this, and then the first one is this, and we get that 5 back. So we run that through multiple times, and we'll just change this to B, and put ground truth back on. And we actually get a smaller number. Oh, yeah, you got 2 back, because if we were to print all these out, you would see that some of them are negative. So we actually end up getting, a couple positive numbers, adding with a couple negative, making it a pretty small number. And with my sample data, or my actual input data, the number was quite a bit smaller for the second solution than the first solution, which kind of makes sense because we're, kind of working backwards, and we will get negatives in that case. So yeah, that's what I came up with. And I'm sure there's, a more concise way to do this. I'm sure there's some math library you could use that would, maybe even do this in 1 or 2 lines. But this is what I have for you today. So thanks for watching. See you in the next one.